Hi, my name is Kenneth Watkins, and we're here to explain to you the principles of non-Newtonian and Newtonian fluids. In the next few minutes, we will explain to you how they work and the differences and similarities between the two.
I'm Justin Kersey.
I'm Jessica Meyer.
Matthew Blocker.
Seth Williford.
And Robert Blunt.
Yeah.
The first type of fluids we're going to talk about are Newtonian fluids. Newtonian fluids are any fluids in which the shearing stress, tau, is linearly related to the rate of shearing strain, du dy, as shown here on this graph. This means that the fluid continues to flow no matter what forces are acting upon it. The viscosity of these fluids depends on the temperature and pressure, not on the forces acting upon it. Examples of Newtonian fluids are water and loose gases.
The group of fluids opposite the Newtonian fluids are called non-Newtonian fluids. With these fluids, the shearing stress is not linearly related to the rate of shearing strain. These fluids can further be broken down into three subcategories. The first of these subcategories is known as shear thickening. Shear thickening non-Newtonian fluids, the viscosity increases as the rate of shearing strain increases. The second type of these fluids is called shear thinning non-Newtonian fluids. With shear thinning, the viscosity decreases as the rate of shearing strain increases. And the third type of these fluids is called Bingham plastics. Bingham plastics have a yield stress, and until that yield stress is reached, they act as a solid. But once it's reached, they flow freely like a liquid, and they return to a solid state once the yield stress is taken away.
Shear thinning fluids are another type of non-Newtonian fluid. They are characterized by a decreasing viscosity with an increasing rate of shear stress. Another way to explain this would be whenever the fluid is not being messed with, it will retain its shape, but whenever a force is applied, it will flow easily. An example of this would be mustard. Imagine whenever you squeeze a bottle of mustard, it's going to flow freely out of the bottle, but whenever it's sitting on a piece of bread, it will retain its shape. Another example would be paint. You can come through, put it on a canvas, it'll stay there, but if you apply pressure to it, it'll flow freely across the canvas. That's it.
One classification of a non-Newtonian fluid is a shear thickening fluid. This is a fluid in which the viscosity and the shear stress go up, increase or decrease at the same rate. One example of this is cornstarch and water, where you use 2 parts cornstarch to 1 part water. As the mixture is forced upon, or a force is applied upon the mixture, this causes the mixture to solidify. Another use in the military is new age liquid armor, in which the liquid armor is combined with polyethylene glycol to cause a material that solidifies and is more flexible than common use Kevlar. The 2 videos you just saw were of Kevlar, one treated and one untreated. The untreated Kevlar allowed the projectile to go directly through the Kevlar, while the treated Kevlar bounced the projectile off. This was due because the treated Kevlar was treated with a polyethylene glycol solution and silica gel. This is put on the Kevlar and then baked off, which makes the Kevlar impenetrable to knives and projectiles. This makes the Kevlar cheaper, easier to make, lighter weight, and will stop projectiles a lot easier depending on the projectile or Kevlar.
A Bingham plastic like Play-Doh or toothpaste behaves similarly to a Newtonian fluid while in stress. It is a viscoplastic material that behaves as a rigid body until a yield stress is applied. Beyond this point, the Bingham plastic flows as a Newtonian fluid with its flow rate increasing proportionally with the increase in shear stress. The reason for this behavior is that the liquid contains particles like clay or large molecules which have a sort of reaction creating a solid structure. Once the structure is broken, the particles move with the liquid under a viscous force, and if the stress is removed, the particles will associate again.
And that was our extra credit video on Newtonian and non-Newtonian fluids. We hope you liked it and have a nice day.